Morning, children. Here today we are going to discuss about working with polynomials. It means verifying coefficients, zeros, and their relationship between coefficients and zeros of given polynomial. Working with polynomials. We have already studied how to find the zeros of a polynomial. For example, if k is a zero of p of x equals to 2x plus 5, then p of k is equals to 0 gives 2k plus 5 equals to 0, that is k is equals to minus 5 by 2. For linear polynomial, in general, if k is a 0 of p of x equals to ax plus b, a is not equal to 0, then p of k equals to ak plus b equals to 0, that is k is equals to minus b by a, or the 0 of the linear polynomial ax plus b is minus b by a. Thus, the 0 of a linear polynomial is related to its coefficients including the constant term. So, we will now try to explore the relationship between zeros and coefficients of a quadratic polynomial. For this, let us take the quadratic polynomial p of x equals to 2x square minus 8x plus 6. So here we take the quadratic polynomial p of x equals to 2x square minus 8x plus 6 and split the middle term minus 8x as sum of two terms whose product is 2x square into 6 equals to plus 12x square. So we write ax square plus bx plus c, ax square into c, 2x square minus 8x plus 6, then 2x square into plus 6 equals to plus 12x square. In product, plus symbol is there. So we add two terms. In product, plus symbol is there. So symbols of two terms should be plus and plus or minus and minus. Particle factors are plus 12x square or plus 1x plus 12x. Adding. So plus 1 plus 12 equals to 13x. Minus 1x and minus 12x. So minus 1 and minus 12 minus 13x. And plus 2x and plus 6x. Here plus 8x. But here minus 8x. So here plus 2 plus 6 plus 8. And next one minus 2x and minus 6x equals to minus 8x. So we get. So we take minus 2x and minus 6x as two terms to get minus 8x. Minus 2x square minus 2x minus 6x plus 6. Here 2x common. From 2x square x remains minus 2x 1 remains x minus 1. And next one minus 6 common. So here x minus 1 remains. So in both terms x minus 1 is common. Then first 2x and second one minus 6. So 2x minus 6 into x minus 1 are factors of 2x square minus 8x plus 6. And p of x is 0 when 2x minus 6 equals to 0 or x minus 1 is equals to 0. 2x equals to 6 or x equals to 1. So x equals to 6 by 2 or x equals to 1, then x equals to 3 or x equals to 1. Therefore, the zeros of 2x square minus 8x plus 6 are 3 and 1. Now, relationship between zeros and coefficients of a polynomial. We now try and see if these zeros have some relationship to the coefficients terms. The polynomial. The coefficient of x square is 2 and coefficient of x is minus 8 and the constant is 6, which is the coefficient of x to the power 0, that is 6x to the power 0 equals to 6. We know. For quadratic polynomial, in general, if k is a 0 of p of x equals to ax square plus bx plus c, k is not equal to 0, then p of k equals to ak square plus bk plus c equals to 0. Then k is 0 of the given polynomial. Here we see that the sum of zeros, already we know zeros are 1 and 3. So sum of zeros, so 1 plus 3 equals to 4. Already we discussed, we try and see zeros have some relationship to the coefficients of terms. So here 4 is sum of zeros. So 4 can be written as minus of minus 8 by 2, comparing with the coefficients. Okay, so minus of minus 8 by 2 is equals to 4. So here minus minus and minus 8 is coefficient of x. So minus coefficient of x and here 2 is coefficient of x square. So here from ax square plus bx plus c, coefficient of x means b and coefficient of x square means a. So minus b by a. And product of zeros, 1 into 3 equals to 3. So 3 can be written as 6 by 2. Here 6 is constant term and 2 is coefficient of x square. So here constant term is c and coefficient of x square is a, c by a. Thus, the zeros of quadratic polynomial are related to its coefficients including the constant term. Okay. For quadratic polynomial, the sum of zeros is relation with coefficients. Yes, here minus b by a, that means minus coefficient of x by coefficient of x square, and the product of zeros constant term by coefficient of x square, so c by a. Next, alpha and beta are Greek letters pronounced as alpha and beta respectively. We will use later one more letter, gamma, pronounced as gamma. Okay. In general, if alpha and beta are the zeros of the quadratic polynomial p of x equals to ax square plus bx plus c, where a is not equal to 0, then x minus alpha and x minus beta are the factors of p of x, because alpha and beta are zeros. So then x minus alpha is a factor, beta is 0, then x minus beta is a factor. Therefore, ax square plus bx plus c is written as k into x minus alpha into x minus beta, where k is constant. So is equals to k into x minus alpha into x minus beta, x square minus alpha plus beta x plus alpha beta. Here ax square plus bx plus c equals to kx square minus k of alpha plus beta x plus k of k alpha beta. Comparing the coefficient of x square, x and constant terms on both sides. We get a is equals to k, b is equals to k into alpha plus beta. A is equals to k, b is equals to k into alpha plus minus k into alpha plus beta. C is equals to k alpha beta. Okay. Now here minus b by a, minus b by a. Here minus of b means here minus k into alpha plus beta, and a means a k. So here k of alpha plus beta by k get cancelled. So alpha plus beta. Then alpha plus beta sum of zeros equals to minus b by a. Next one c by a. So here c k alpha beta a k. So k get cancelled, alpha beta. So alpha beta equals to c by a. Now in general, if k is the 0 of p of x equals to x square plus bx plus c, k is not equal to 0, then p of k equal to ak square plus bk plus c equals to 0. So the sum of zeros of a quadratic polynomial alpha plus beta equals to minus coefficient of x by coefficient of x square, means minus b by a. Next, the product of zeros of a quadratic polynomial alpha beta equals to constant term by coefficient of x square is equals to c by a. Thus, the zeros of a quadratic polynomial are related to its coefficients, including the constant term. Are the zeros of highest degree polynomials also related to their coefficients? Yes. We now try and see if the zeros have some relationship to the coefficients of terms in the cubic polynomial. Here we take the coefficient of x cube is 2, x square is minus 5, x is minus 14, and the constant is 8. In general, if k is the 0 of p of x, ax to the power 3 plus bx square plus cx plus d is not equal to 0, then p of k equals to ak cube plus bk square plus ck plus d equals to 0. Let us consider p of x equals to 2x cube minus 5x square minus 14x plus 8. We see that p of x equals to 0 for x equals to 4 minus 2 1 by 2. Since p of x can have at most 3 zeros. These are the zeros of 2x cube minus 5x square minus 14x plus 8. We see that the sum of zeros 4 plus minus 2 plus 1 by 2 equals to 5 by 2. Okay, 5 by 2 can be written as minus of minus 5 by 2, then minus, here minus 5 is coefficient of x square, so minus coefficient of x square by coefficient of x cube. So here coefficient of x cube is b, and coefficient of x square is b, and coefficient of x cube is a. The product of zeros 4 into minus 2 into 1 by 2, we get minus 4. So here minus 4 is written as minus 8 by 2. So minus constant term by coefficient of x cube. So here constant term is d and coefficient of x cube is a. However, there is one more relationship here. Consider the sum of the products of the zeros taken two at a time. We have here 4 and minus 2. So 4 into minus 2. Next time minus 2 into 1 by 2. So and next time 1 by 2 into 4. Now add them. 4 into minus 2 plus minus 2 into 1 by 2 plus 1 by 2 into 4. We get minus 8 minus 1 plus 2 equals to minus 7. So can be written as minus 14 by 2. Here minus 14 is coefficient of x and 2 is coefficient of x cube. Here coefficient of x is c and coefficient of x cube is a. So here sum of zeros, product of zeros, and another relation is sum of product of zeros taken two at a time. Now alpha and beta and gamma. In general, if alpha, beta and gamma are the zeros of cubic polynomial, p of x equals to ax cube plus bx square plus cx plus d, where a is not equal to 0. Then x minus alpha. Alpha is 0. So x minus alpha is a factor. Beta is 0. So x minus beta is a factor. Gamma is 0. So then x minus gamma is also factor. Now it can be written as x minus alpha into x minus beta into x minus gamma. Now, so here we get x cube minus x square of alpha plus beta plus gamma plus x of alpha beta plus beta gamma plus gamma alpha minus alpha beta gamma. Compare with polynomials, we multiply by a and get ax cube plus bx square plus cx plus d equals to here a into x cube minus x square into a into alpha plus beta plus gamma plus x into a into alpha beta plus beta gamma plus gamma alpha minus a into alpha beta gamma. So here comparing the coefficient of x cube, x square, x and constant term on both sides. So here x cube coefficient is a, here also x cube coefficient a, and we get a is equal to a, b is equals to minus a of alpha plus beta plus gamma, c is equals to a of alpha beta plus beta gamma plus gamma alpha, and d is equals to a of alpha beta gamma minus a of alpha beta gamma. Here d is equals to minus a alpha beta gamma, here minus a. Now alpha plus beta plus gamma equals to minus b by a. Here sum of zeros of the cubic polynomial. Coefficient of x square by minus coefficient of x square by coefficient of x cube. Sum of product of zeros taken two at a time. So here alpha beta plus beta gamma plus gamma alpha. So c by a. And next one coefficient of x by coefficient of x cube, alpha beta plus beta gamma plus gamma alpha. Now product of its zeros minus b by a. So here alpha beta gamma. So minus constant term by coefficient of x cube. Okay. For cubic polynomial, alpha plus beta plus gamma equals to minus b by a. Alpha beta plus beta gamma plus gamma alpha equals to c by a, and alpha beta gamma equals to minus d by a. Thank you. Keep watching.